morning. Welcome back to another episode in the series of Mastering Diagnostics with yours truly, Brandon Steckler, technical editor of Motor Age magazine. Today is video 6. And video 6, I want to base off of bidirectional scan tool controls to help divide and conquer. Now, here's what I'm getting at. First, let me back up and say that being a diagnostician, many people think that you got to be the smartest person in the room, and that's not necessarily true at all. Matter of fact, ask my friends how smart I am. They'll tell you. I am no smarter than anybody else watching this video. I just happen to know a little bit differently. And what I want to mention is this. Vehicle technology today, compared to years past, we all know, has increased heavily, making vehicles from some aspect a bit more difficult to diagnose because there's so many layers of complexity added to what was already challenging us in years past. But the good news is, with these layers of complexity, leaves opportunities for us to grab data, and to do so in a very easy to perform fashion, right from the driver's seat, right from the data link connector, if you will. And what these are going to allow us to do is make some diagnostic decisions about what's going on within the vehicle, within the system that seems to be housing the issue that the customer is complaining about. So again, back to what I was saying about being intelligent or being smart, it really has not much to do with it as far as, skills you're born with versus ones you develop over time. If you take the time to reference some basic information about the system, about the components of that system, and how they work together as a system to accomplish a goal, you can learn a heck of a lot about the vehicle you're troubleshooting. And with that, you can learn how to approach it in a systematic, logical, and efficient approach. By doing that, it gives you an opportunity to grow your basic knowledge about how things work in general within the automobile platforms we handle on a day-to-day basis. And with that, it will allow you to not only repair the vehicle or diagnose the vehicle efficiently, but it will also help boost your confidence, helping you have better, more productive days at work, which is great for the wallet, it's great for the boss, and it's really great for the customers as well. So here's the story with this vehicle. The subject vehicle is a 2006 Chevy Silverado with the complaint that the right side power window doesn't work. It doesn't go up and it doesn't go down. It doesn't work at all. After speaking with the customer, they can't seem to roll the window down from the passenger window switch, nor can they roll the window down from the driver's side master switch. So our approach to this is going to always be in a logical fashion. I'm inherently lazy, and I want to find out as much information about the subject vehicle's system as I possibly can. Because as we all know, there are many, many ways to skin a cat. And relating that to vehicles, there are many, many ways to make a power window go down. How this vehicle is, I'll use that keyword, configured, how it's put together, how that system is arranged, those components work together to accomplish a goal. That can vary from vehicle to vehicle. Even if it's the same year, make, and model, even a different trim level can rearrange how those components dance together. So we are going to take a systematic approach to finding out how the system works, and we're going to do so by referencing some service information whenever possible. I want to get a description of system operation. I want to read some verbiage about how these components work together to give me some anticipation of what is to be expected when I reference part 2 of service information, and that's going to be a wiring diagram. As I'm reading the information on how the system works, I'm referencing the wiring diagram simultaneously to follow along, if you will. And then once I have that, I'm going to be using a capable scan tool that is going to allow me to speak with the components that are responsible for carrying out these goals. That scan tool of choice today is going to be the Bosch ADS 525X. There are many capable scan tools out there today, but I'm going to try my hand at this one with this specific problem. So once I have the scan tool in hand, I'm going to be able to manipulate the systems. We're going to be checking for DTCs. We want to see who's complaining about what, if at all. And then we're going to be using some different modes of operation with this scan tool to A, monitor inputs and monitor outputs. To do that means to virtually split the system in half. If I can look at the data from a computer, let's say halfway through the system, and that computer is indicating to me via my scan tool data list that it could see me press the button, in this case for the window to go down. Isn't it true that I've already accomplished half of my goal? I've eliminated the input side of the system. Now I can switch over to a different mode of operation with the scan tool and take command of these components with bidirectional control. Using the scan tool and initiating an output from bidirectional control, I can force, in this case, the power window to roll down if I desire, or roll back up. Now, whether that happens or not is the story to yet be told. But that's also part of the story that's going to tell us which direction to head in. Keep in mind, I have not even left the driver's seat at this point in time. So again, if you could see the method to my madness, we're going to be gathering some information to make diagnostic decisions. And each decision we make is going to lead us to the next logical decision. That's what today's Mastering Diagnostics video is all about. So after doing some research here through system description and operation in my service information source, we see that the passer window switches incorporate window up and down relays. So relays, when they operate, they should be audible. So this might be able to give us a clue. If we can operate the window from the switches and we hear the relays clicking, it may be able to offer us a clue about what components are functioning in this system, leaving us less to test. So initially I am looking at the driver's door module, as we can see here. And these are our window switches. Now, this schematic is written to incorporate a configuration for a 4-door truck. This truck is 2 doors with 2 extended cab doors without windows. So some of this stuff is to be ignored. As it says here, crew cab only. We can ignore that. But our driver's door module, where our switches assembly is housed, our power window circuits are found here. This is for the driver's window. The passenger window is not on this screen, so we're going to have to switch to a different schematic because it appears information is being shared on a Class 2 serial data network. So we'll change schematics to where this would continue here and get a look at the passenger power door module. So we're over on our second page of our wiring diagram, and I know it's a bit difficult to see, so bear with me. I'll point out the components as we go along. So here is our passenger door module, along with the passenger door window and window motor assembly. Over here is our driver's door module, which carries the request from our switch to the passenger door module. Now they are connected via a communication network, the Class 2 serial data bus. Now it goes elsewhere to the body control module, and we can reference some more detail at the DLC schematics, but we see all what we need to see here because although this is broadcasted to all of the other nodes, only the passenger door module uses it. So it begins here at the driver's switch, the driver's door panel, master switch. And we depress the down button. The signal here is being manipulated by the switch, which signals the driver door module the request for the window on the passenger side to roll down. At this point, the driver's door module is going to output or broadcast a Class 2 serial data bus network signal through the network, making its way back to the passenger door module. Now, it's the passenger door module's job to create the output, to energize the motor. And there are two drivers here. There's one driver to energize one side of the motor, and there's another driver that energizes the other side of the motor. When the drivers are at rest, they are referenced to ground, as we can see right there. So since we are commanding the motor down, you'll see that this side of the motor, the up side of the motor, is going to be referenced to ground because this driver is at rest. It is not being energized. So the ground path will be established there, providing a ground path for the motor. When we push the down button, this driver that is shown at rest at ground here is going to switch over and make contact and allow switched voltage to make its way to the motor. Now we all know if the motor has voltage and ground and the motor has integrity, current will flow and that motor will operate as such. So if we were to look at this as we did now, we've built anticipation on what to expect during testing when we make our way out to this power window switch on the passenger door. Judging by what we see here, we should anticipate 12 volts being available there. And if I measure on the other side, I should see nearly 0 volts right there. Now, none of this would be possible unless the system has adequate voltage supply, like we see here, providing voltage to our switch. And what's not drawn here because it continues on another page, but rather than switching pages, I'll just draw it there for us, is a path to ground. So we have a brown wire, which is going to be energized at 12 volts when we push down. Our dark blue wire at our connector number 1 should reference near 0 volts. And a black wire, which is, again, I've drawn here, but it is not present in this picture, should always be referenced to ground. So, after some simple research, taking our time, spending some time in front of the computer and building a game plan, we finally established one. So let's head out to the vehicle and get started on this and hopefully come up with a diagnosis through a process of analysis quickly and efficiently.
Well, we're here at the vehicle and we can operate the window switches and the window does not work. I performed a full system scan. Probably difficult to see on camera. But there are no DTCs pertaining to our driver's door or passenger door modules. So after scanning for DTCs and not really getting any sense of direction from there, we're going to reference the data stream for the passenger door module. And what we're looking for specifically is to see if the passenger door module is receiving a command via our Class 2 data bus from our driver's side door module power window down switch. So I'm going to operate the window motor down. It's expressed down. There's down. I'm going to operate it up. And it's up. So what's to be derived from that information we just gathered? It says that the power window master switch is sending a signal, A, and B, the passenger side power window switch assembly, the door module itself, is receiving that signal and processing it. Why? How do I know that? Because our scan tool has displayed that for us. All that information is communicated on this vehicle's Class 2 data bus. So now it's time to move on to bidirectional controls to see if we can command it down. So at this point, it's time for us to move to some hands-on testing. Now, that's what I would normally do if I didn't have a capable scan tool. But this scan tool, this Bosch ADS 525X, offers bidirectional control. We're going to enter the scan tool and enter the systems via the scan tool and take control of the power windows and see if we can make them operate. So we will enter special tests. And we know the driver's side functions. Let's take control of the passenger side and see what we can do. So inside the passenger door control module, we have a couple different functions. We are going to select mirrors, or door locks, or key fobs, or in this case, windows up and down. So I'm going to use the bidirectional control to split the system in half, input versus output. Oops. So let's attempt to roll the passenger window down. And up. The window doesn't move. However, listen carefully. Those are our relays inside our passenger window switch assembly. So let's think this through from a logical perspective. Through bidirectional control, by commanding the power window on the passenger side to roll down, the window didn't function. However, we did hear the relays click. So question number one is, what does that say about connectivity on our Class 2 data bus, the one that delivers the message from the driver's module to the passenger's module? It says it's intact, because if it wasn't for that system being intact, there's no ways those relays would attempt to operate. So the fact that the relays are operating tells me a lot about the system. A, it's seeing our input, our request to roll the window down. Two, it's intact because we have established communications and there are no DTCs to indicate a lack of communication. So this pretty much leaves our fault on the output side, on our passenger door module leading out to our power window assembly. So the question then becomes, where do we begin to test next? Where do we want to put our hands first? And that answer is always going to be whatever's easiest to access. So the first thing we're going to have to do is test our equipment. So I'm going to reference my DVOM to inadequate ground and voltage supply and make sure it registers on the display what I anticipate. This way I know I can trust my equipment. I've referenced my ground cable to the vehicle's chassis, and we are going to test for adequate voltage supply at this auxiliary power source. And as we can see, near battery voltage is present. We know we can trust our equipment and its connections. And now we're going to gain access to the connector so we can verify we've got proper voltage and ground feed where it's supposed to be when we operate the power window switch in the down position. So first we're going to check the orange wire, which is our voltage source wire. And there we have it. So voltage is available. Now we know voltage is available to the switch. So I'm going to operate the switch now, and hopefully that 12 volt source that we just tested, it's going to make its way through the switch and out to the power window assembly, through the assembly, and back to the switch again on the ground side. So our orange wire is our source coming in from a fused and we've got 12 volts available. Now we're going to move over to our brown wire, and the brown wire should have 12 volts on it when the switch is placed in the down position. So I'm touching the wire, switch is in the down position, and we have 12 volts leaving the switch. Before I take the door panel apart and make my way back to the motor, I can do another test to help infer what's going on. I'm going to now go on the blue wire. The brown wire feeds voltage to the motor, and it's this blue wire that carries that voltage back to ground, allowing the motor to operate. That should be at 0 volts when I push the down button. And it is at 12 volts, indicating we have lost the ground path. But what it also indicates is that we have continuity through the motor. What can be seen is the blue wire had become disconnected or unmated from the connector. That connector position assurance tab was not secured properly. What that means is voltage command from the switch came in through the brown wire, made its way out to the power window motor assembly, went through the motor and made its way back towards ground through the blue wire. But since the blue wire was not coming in contact with the switch assembly, it couldn't reference ground on the black wire. After close examination, it's determined that this terminal has been spread, meaning the contact between the male and female are not occurring. So what we're going to perform next is a bypass test. This bypass test is going to allow me to make a temporary repair to the circuit to verify its fix. Before I tell the customer we have to repair this wire and potentially have a secondary fault that's leaving this window inoperative. So I'm simply going to use a fuse jumper wire, which is going to connect this blue wire to the connector as it's designed to work. And the window operates just fine in both directions.
Now we are looking at the same exact circuit. Nothing's changed except the fact that we have lost our ground path here. For some reason, we can't make it back to battery. So again, 12 volts originates at the battery, and 12 volts of electrical pressure is found on the brown wire leading to the motor. The voltage pushes electrons through the motor onto the negative side here, the blue wire. But since there's no ground path, electrical pressure is the same on both sides of the motor, 12 volts and 12 volts. And if we go back to our meter, our red meter lead is measuring 12 volts. Our black meter lead is also measuring 12 volts, meaning the difference between the two is 0 volts. So without any difference in electrical pressure from one side of the motor to the next, electrons can't flow because it's like a stalemate. There's equal pressure on both sides. So this is the reason the motor won't work. There's 12 volts on both sides of the motor. And the reason there's 12 volts on both sides of the motor is because there is no path to ground. We might as well draw this switch open or create a break in the wire here or here. The second thing I want to point out, as I referenced in the video, is that because we are measuring 12 volts here, it says that there is continuity through the motor all the way through this wire. So it would be premature of us to remove the door panel and go test at the motor. There's nothing wrong with doing that. You would certainly come up with the same answer. However, it's a bit more time consuming. So the fact that I verified I have 12 volts available here and 12 volts available here infers to me that this circuit is complete. It doesn't prove the motor is healthy. It just proves we are not dealing with an open circuit upstream of these connections right here. The problem is between here, where we measured, and battery ground. And of course, that's where we found two problems. We found a dislodged terminal that was not properly secured in the connector housing. And upon further inspection, we found the spread terminal. We repaired the connector properly. Now it's time to reinstall it and verify the fix. Well, that was fun. But to recap on what we set out to accomplish today, and what we did accomplish today is a streamlined approach to diagnostics. We consulted with the customer, determined what the problem was. We asked a few questions about which window switches the fault occurred to them, and both of them in every direction. We utilized the scan tool to check for DTCs, which may have given us some information pertaining to perhaps a data bus issue, a loss of communication from one computer node to the next. But we didn't have that. We were able to use the scan tool, excuse me, PID list to monitor for inputs versus outputs, and the inputs the inputs that were visible on the screen indicated that our computers were indeed seeing the switched inputs occurring when we depressed the switch for open and for closing that window. We moved on to bidirectional controls and attempted to operate the window. And although the window didn't function, we did audibly hear the relays in the switch assembly functioning, proving we have communication, system integrity. Voltage and ground are available to that Windows switch assembly. It can communicate, and it's able to carry out the function, process the request we sent. The best part is all that was derived right from the driver's seat, leaving us for hands-on testing in a very limited area. The easiest place to access is the switch. It took only a few moments to pull that up. Verifying, after referencing the wiring diagram, that voltage was present to the window motor connector at that switch when we energized the down button, initiated the down button. However, voltage was available also on the blue wire, which was supposed to be a ground path, indicating the path to ground was broken. Finding first a loose terminal was not secured properly, and then checking to find that the terminal was indeed spread, we then used a bypass test, a fused jumper wire, to make a temporary connection and reestablish that circuit connectivity, proving the system to be functioning again, all without taking anything apart, really, just removing the switch from the door panel. Why this is so important, although this was a very simple problem to find, this same logic can be applied to any problem you encounter on today's automobile. By doing so in the fashion that we did, we can consult with our service advisor and tell him or her what it is we found. Now, here's the takeaway from that. If Mr. or Mrs. Customer decides they don't want to carry through with the repair, they're only paying for diagnostics. In this scenario, if we had charged 1 hour for diagnostic time, I probably had about 10 to 15 minutes involved in the process. So if the customer chose to not repair the vehicle properly, but instead chose to leave with that diagnostic evaluation that they paid for a full hour. They got a boatload of information for that hour of invested time. And we only invested 15 minutes, but collected an hour of labor. Now, on the flip side, if they chose to repair that vehicle, we could capitalize on not only the diagnostics, the efficiency of our diagnostics, but the efficiency of the repair. And I think an even bigger takeaway from this experience than repairing the vehicle and diagnosing it efficiently is the fact that the research we are forced to do preliminarily allows us to gain some insight, gain some knowledge, grow our knowledge base, and become a better technician for it. So in essence, we are truly slowing down to speed up, and this makes us more efficient. And when you are more efficient, you're more confident and more profitable in the shop. So thank you for joining me on this edition of Mastering Diagnostics, Video 6 with me, Brandon Steckler, Technical Editor of Motor Age Magazine, and look forward to seeing you next time in Video 7. Take care.